Alright, so we continue from question 2. We have already solved the question 1. So let's continue this video. Solve the following differential equations. Solve the following differential equations. Now, the most interesting and loving thing about OD is that we have looked at a lot of techniques, separable and whatever. But again, after separable, homogeneous, equation reducible to homogeneous, and also we have also done after homogeneous, reducible, homogeneous, and what again? Exact differential equation. So when the question is given to you, you have to analyze. It's like solve the following differential equation. It's the same as what we are doing in separable. Now, you don't know whether it's separable or not. So you have to check, can this be separate? If it can't, then you go, is this homogeneous? Well, this, it can be homogeneous, right? And you know how to verify whether it's homogeneous or not homogeneous. We have done that. Yes, you can't tell me no. We have done that. So with this, in fact, let's go straight to the point. It's falling under exact differential equation. But I just want to project to you that if it's an exam time and the question is there, and the question is there for you, you have to analyze it yourself, whether you are going by this technique or that technique. That one, make sure. That is why in all the techniques, we look at how to verify it first. Very good. So let's start with the first question. So we start with the first question. But the first thing to do is to check if it's exact or not exact. So here we have x raised to the power 4 minus x Alright, so we first check whether it's exact or not exact. So let's determine the function of f in terms of x and y. So that is the one attached to ds. Then we find the partial derivative of n as respect to y. And we treat s as constant. So here you can see that this is the same as m subscript y, and that is going to be 1. Because this is already 0. Then we identify our n in terms of x and y. And that is going to give us. Now please note that the total differential is in the form m ds plus n dy equal to 0. Here is plus. So you have to be careful if you want to identify the n here. Even though if you choose this n to be x, you'll be doing the right procedure although, but everything is wrong. Because n is negative. So here, if I'm to be you, I'll rewrite this one well, okay? Because we know that this is going to be plus negative of this. So here is negative x. So you take the partial derivative of n as respect to x, and that will give you negative 1. Now, you don't need somebody to tell you. You don't need somebody to tell you m subscript y is not the same as n of x. Okay. So if it's not exact, then let's move on to find the integration factor. So finding the IF. My marker is not flowing well for me. I'll be back. Alright, so in finding the integral factor, you know we have two ways or two cases, whether it's going to be in terms of x or y. Alright, so looking at this, let's go straight to the point. This is going to be in terms of x's, and you can check with that. You can check that with the one that is in terms of x is my minus nx. My, look at the my is 1 minus mx, nx, and nx is negative 1. So the numerator is going to be constant. Then let's look at the denominator. The denominator is going to be n. The denominator is going to be n. And let's look at the n here. The n here is this, and that is negative s. So that is going to be simple for us. But if you go and choose for in terms of y's, that one is going to be nx minus my. Nx minus my. The numerator is going to be constant, alright, but the denominator is going to be m. It's going to be m. And we have m to be the whole of this bunch of stuff. So you can see that even without working it, you can just estimate it and see what it's going to help you. Alright, so we choose the function of in terms of x's, and that is going to be the integral of very good. So let's go for this. Let's take only the inside. Okay. So that is my minus nx over n. And that's going to give you my is 1 minus nx negative 1 over n. N is negative x. So this is going to give you negative 4. So that is going to be positive there. So we are going to get, so for that, we get 2 over negative x. So we are going to end up by getting negative 2 over x. So that is not the integrating factor. So the integrating factor in terms of x is going to be the integral of, let's factor negative 2 out. Here will be 1 over x dx. Alright. And this we are going to get negative 2 ln x over e raised to the power that. And with this, we know that here is going to be e raised to the power ln s negative 2. And this is going to give us s raised to the power negative 2. So that concludes that our integral factor is going to be 1 over s raised to the power 2. So this is our integral factor. Now we take the integration factor to multiply the total differential. Alright, so now 1 over x squared will now multiply. You know what you're doing already. To multiply this. Alright. So here we are going to get x squared minus 1 over x plus y over x squared dx plus, but here is going to be minus, but if you don't want to confuse yourself, just remain it. Negative 1 over x dy is equal to 0. Very good. So that is what we are going to have for that part. So here we get our new, yes, I will say our new question to find the general solution. All right. So you know how that thing here already. So now here we go and find the partial derivative of m as respect to x. Sorry, y. Here we treat s as constant, 0, 0. So here you are going to get 1 over x squared because we are treating s as constant. And when you differentiate y, you get 1. Partial derivative of n as respect to x. We treat y as constant. There is no y here. So when you integrate this, what are you going to get? Now watch. Know that this is like this, alright? So we get here to be positive. So that will be negative 2 when you subtract 1 from it. So this is the same as 1 over s squared. Alright. So now you can see that it's exact. In fact, if only your integration factor is correct, definitely when you multiply through it and you don't commit any algebraic mistake, then it's supposed to be exact. It's a theorem, and whether you like it or not, it has to work. It has to work. Alright, so now that it's exact, then we now continue to find our general solution. Alright. In fact, I would like to fill the question. So we now move on to find the function of u in terms of x and y. So we integrate, and the integration, we are going to pick the part that when we integrate, we are not going to suffer. Yes, when we integrate, we are not going to suffer. Now let's look at it. What are you going to pick? I'm coming. Let's pick that. That is partial derivative of u as respect to x and partial derivative of u as respect to y. Alright. And you know that the one as respect to x is going to be this. And that is x squared minus 1 over x plus y over x squared. Alright. The partial derivative of u as respect to y is going to be negative 1 over x. Very good. So now we move on to find the general solution. So we are going to pick the one that the integration is going to be easy for us. Now watch. When you pick this, it means that you're going to integrate as respect to x. And see, this is bunch of stars. And when you're integrating as respect to x, you treat y as constant. So you integrate this, then this is going to be bunch of steps. But let's pick the one that you're going to differentiate as respect to y. You can see this is just negative 1 over x, and this is going to be easy for us because here we are integrating as respect to y. So we are going to treat x as constant. So when we pick that one, it's going to be easy for us to solve it. Alright. So when we integrate as respect to y, we treat x as constant. So if this is a constant like 2 and you integrate, you get 2y. So here we're just going to get negative y over x plus the constant, which is g of x. Or we can make it h, it's still the same thing. Very good. Very good. So that is exactly what we are going to have. Then we move on to take the partial derivative of the u as respect to the part that we didn't integrate, and that is y. Alright. Now when you are doing this, you treat s as constant. So here you get negative 1 over x. Exactly. Plus h prime of x. H prime of x. Then let me check one. Oh, the mistake is here. I thought that we integrate as respect to y. We integrate, as respect to x. We integrate as respect to y. So here supposed to be as respect to x. That is the part that we didn't integrate. So we treat y as constant, and when you differentiate 1 over s, you are going to get negative s, negative 2. So this is negative 1 over s squared. Alright. Negative 1 over s squared. And now, this negative will come and undo what is here. So what is here will be, what we have here is this. We have negative y already, we'll come and multiply negative 1 over s squared. So you can see what you are going to get, and that is going to be y over s squared plus h prime of x. Alright, you can even pause the video and solve it on your own. Oh, I have still important parts, but don't worry, I still have it. So here that we equate this side to this side. So we have s squared minus 1 over s plus y over s squared is equal to y over s squared plus h prime of x. So something will kill a man. Something will kill a man, whether you like it or not. So here we are going to learn h prime of x is equal to s squared minus 1 over s. Very good. So that is what we are going to have. Then we integrate. We integrate to undo it. Integrate as respect to s. And that is going to give us s to the power 3 over 3 minus. When you integrate it, you get me. This is not linear, but absolute of x. Alright. Then you come back and do the substitution to what we have here. So finally, fact, this is just simple. Once you know your integrating factor, everything is just simple. Finding the general solution shouldn't be the problem for you. Then you equate it to C, since it's a general solution. Alright, so you can choose to continue to play with your algebra, but I would like to end it with this one. Alright, so that is the general solution for our question 2. Let's move to question 3. Alright, so let's go straight to the question 3 and so. Now you can see that the question here is not, the equation is not in the form that you are used to it. The one that we are used to it is all inside of what? A bracket. So let's expand it. Then we identify our multiply this by this 2y squared, multiply this by this 2y. Then we check if it's exact or not exact. So here we get 4y minus 2. Don't forget, this is the same as m subscript y. This is the same as n subscript s. So we treat y as constant. So we get 2y minus 1. Then we now you can see that this is not the same as this. So m of y is not the same as this. And saying this is not the same as this, we are saying that it's not an exact differential equation. So if it's not exact differential equation, then we go for the IF, which is the integrating factor. Now, that one we are going to look at, is it going to be in terms of x or going to be in terms of y? Alright. So let's first do a of x before c. We know that it's whether you are subtracting this from this or subtracting this from this and taking it over something. Now watch. We know whenever we subtract my from nx, we divide by the n. It's easy for you to know the formula. Now, when you subtract this from this, what will you get? And when you divide by this, what will you get? You can see that that is going to help us. In fact, I don't know if you have seen it or not, but let's try it and see. The one in terms of x. In case you can't do it up here like what I was doing, don't worry. You can check for the truth and look at what's going to help you. So let's first try for this. So that is so we do the middle first. And the middle is what I did up here to see that it will work. M of y, M subscript y We divide it by n, and the n is this. Now watch. Here's what I was doing okay. With this, we can factor s out. Now, looking at what we have here, you can see clearly that the top is going to be in terms of y, the numerator. So watch what? This to this, you get 2y. Then this to this, you get minus 1 over x 2y minus 1. That is why we have factored the y and the x out here. So this is exactly this. Beautiful. So the inside of the integrating factor is going to be 1 over x. So we now have encode that our integrating factor is going to be integral of 1 over s dx. Then you take this, then you know that this is going to be ln x e raised to the power that. Very good. Very good. So that is that. That is that. That is that. Now, when you integrate 1 over s as respect to s, you get ln s. And you know perfectly that this will cancel this. So we are going to be left with x. So we are going to be left with x. Therefore, the integration factor is going to be x. So now that we have the integration factor to be x, the next thing that we are left to do is to multiply the integration factor by the whole of this to undo the exact differential equation for it to be exact. So instead of multiplying by this, multiply by this. Two sy squared. Alright, so having this, then let's now go and check if it's going to be exact. Yes. The fact that you call this integration, you call it integrating factor, but it may be that you committed an error. How would you know? Alright, so when you multiply by 8 and now check if it's exact and you get it to be exact, that makes it a correct integrating factor. But if you multiply and you are still not getting it, that means that there is a mistake somewhere. So this is going to give you, we treat x as constant, so we get 4xy minus 2x. We treat y as constant, so we get 4x y. We are treating y as constant minus 2x. It's not that I'm looking at it to copy the same thing. I'm differentiating it as respect to x. by treating y as constant. And this is exactly that. This means that the n of y is equal to the n of x. That makes it truly that x is the integrating factor. Please, I hope you are getting the flow. Very good. So now then we can move on, please, with this. I would like you to move on with it. Move on to use this to find a general equation. The general equation for the exact differential equation. So we identify our partial derivative of u as respect to x and partial derivative of u as respect to y. The one as respect to x is this. Alright, so then we go for this, the general solution. We pick the one that the integration is going to be easy for us. Now look at it, we are going to integrate this as respect to x by treating y as constant. Is it going to be difficult? What about integrating this as respect to y by treating x as constant? You can see that by treating x as constant here, 0. So that will be easy for us. So let's ignore going by this and go for this. 2x squared y minus x squared. I like what I do that I will get 0. Alright. Now, integrate as respect to y by treating x as constant. So this simply, you are going to get 2x squared y squared over 2 whole. This is 0. And this will cancel this. Oh, in fact. Plus, don't forget this, h of y. H of x. In fact, always pick the one that the integration is easy for you. So this will be x squared y squared plus h of x. Then you take the partial derivative of u as respect to x, since you integrated as respect to y. Of this, so we treat y as constant, so we get 2x. 2x y squared plus h prime of x. Then we equate this to the part that we didn't use, and that is 2xy squared minus 2xy. Hope you are following. Is equal to 2xy squared plus h prime of x. This will cancel. Oh, sorry, yo. One. This will cancel this. In fact, I like canceling something out whenever I'm having a bunch of stuff, so that it will be easy for me. So I was in hurry to do that. Don't worry. So h prime of x is equal to negative 2xy. Alright, then what do? We integrate both sides as respect to x and as respect to x. Okay. So here we get h of x is equal to. Now we are treating y as constant. So we get negative 2x squared over 2y. Treating y as constant. So forget about the y. Okay. So we get this for integration. This cancel this. H prime of x is equal to negative x squared y. Very good. Then we move on to conclude to write the general solution. So the general solution will be copy. So just copy this, alright, just copy this. S squared plus S squared times y squared plus h of s, and that is minus s squared y equal to c. So we get s squared y squared minus s squared y squared. So that is the general solution. Now, in case initial condition is given, hope you know how to go about it. So this means that your y, your s is 0, so here will be 0 minus here will be 0, because your y is 0, and or let me change it. Let me make here 1 and make here 0. This means that your x is 1 and your y is 0. In fact, it's the same thing, because here will be 0 minus 0. So c is equal to 0. Then you come back to do the substitution, you get s squared y squared minus s squared y is equal to 0. Alright. So you end up by getting s squared y squared equal to s squared y. So in fact this will cancel out, and you are going to get y squared is equal to y. And this is even y is equal to 1. So this is a particular solution, and this is a general solution. Thank you. Now, let me see if I can help you with question. We now move on to question 4. Please let me leave the question 4 for you to do it yourself, okay? Okay, so let me help with question 5. Let me help with question 5. Go and do the 4 yourself. And even at question 5, I will not conclude to find a general solution for you, but you go and find the general solution by yourself. I'll help you by getting the integrating factor. Then we move on with the rest. Alright. Please, I don't want to go by that. This is not a that. And if it's not a that, what do you go about the integration factor? But you still need that is why you have to check, because you still need it. So you let me do that. Partial derivative is as respect to y. We treat s as constant. So we get 2x plus, treat s as constant. Treat s as constant. We get 2s plus, treat s as constant. We get s squared plus, treat s as constant. We get 3 will cancel 3, so y squared. Alright. Then we go to n. Then that one too is going to be x squared plus y squared. X squared plus y squared. So we treat y as constant. So we get 2x. Y as constant, so this is 0. So this is not exact. So we go on to find the if. So let's first try the one in terms of x. And if that couldn't work, then we go for the one in terms of y. So that is m y minus nx. And if this is here, I don't need to think of what should be here. It's the same as the one here. In fact, the more you solve the questions, the more you get used to the formulas. Alright, so let's pick the inside. So my, the my 2s plus s squared plus y squared minus ns, and that is 2s over n, and that is s squared plus y squared. So we end up getting, wow, this cancels this. So we get s squared plus y squared. Wow! Hope you can see what you are getting. First of all, this cancels this. Secondly, we are left with this. S squared plus y squared. Woo! Which is 1. Very nice. So this means that by substitution, the integrating factor is going to be the integral of 1 ds, and the integrating factor is going to be. Now continue to solve it. So I have the integrating factor here, which is e raised to the power s. So you now go and multiply this through this. Then you check if it's exact. In fact, it will be exact. Then you go on to find the general solution by checking the one that when you integrate. I hope while I'm talking, you're doing it, or you're waiting for me. I want to solve it. So you go on to check the one when you integrate, it's going to be easy for you because you are integrating to treat y. And if you are integrating as respect to s, it means that you are treating y as constant. So when you multiply by 8, that will show you the one to know about 8. Very good, and thank you for this video. Now, all that we have been doing is using the integrating factor to undo the differential equation for it to be exact in order for us to find the general solution. Now, the next video is going to be interesting. You can see now that definitely all that we have been doing is whether it's in terms of x or depending on x or depending on y. We are going to another video whereby you are not going to see it to be depending on only x or only y, but rather both. That is x and y. And when that happens, how are we going to solve it? Oh, well, there is always a way out. That's why you have to thank our way back mathematicians, most especially Isaac Newton, Gottfried Leibniz, and the rest. In fact, they really do well by getting us all the methodologies and the techniques in going through it. So if it's not like that, doesn't mean that is the end for people to laugh at us that, oh, mathematicians, you mean you can't continue with it? Then they come out with integrating factor. And now the integrating factor is not doing all. It's doing when it is in terms of whether x's or y's. So what if is dependent on y? In fact, see you in that video. But until then, please take your time. I would like you to share this video to all your friends in tertiary institutions doing mathematics as a step. Alright, very good. And also, I would like them to, and you watching me, if you haven't subscribed, in fact, you are not doing the best. Go back to YouTube, search Math Expert. I don't know if you downloaded this video by your own or it was given to you by a friend. Don't worry. Go back to YouTube. Search Math Expert. We don't add S to it. It's just like this, Math Expert. Go back to YouTube. Search for it. You will see our logo there. Then you go and subscribe to our channel. Then you turn on the notification panel so that anytime that we drop a new video, you are going to get the notification. Alright, thank you and see you in the next video. Bye bye.